The neutrons. Hello, Eunice. I hope I'm not pronouncing your name wrong. But I do tutor in Chem too. Yes, I do. Yes, I do. All right. So yes, there I am now. I am live on YouTube. So if any of you all need any help with anything, let me go ahead and share my screen at this moment. Okay. So that I can get you guys what you need at this time. So I'm going to actually be going over general chemistry 1 information, but if you have general chemistry 2 questions, I can help you with that as well. And so if you got questions, hopefully I've got the answers for you. Okay. So tonight I wanted to kind of go through atoms like with atomic structure because so many students are going to be taking the TEAS test. Okay, T, week 3 of your 5-week chemistry class. Okay, T, what are you all doing right now? Is there anything that you need specific help with? At week 3, you guys should be doing like stoichiometry, like balancing equations and all that good stuff. Oh, you're welcome, Nye Eunice. You're welcome. Molar solubility. Okay, let's see what I can do for you. So this is a general chemistry 2 question. Okay, molar solubility. I believe I did something like that earlier. Let me see if I can pull some of my notes. So you said molar solubility. Okay, so I'm gonna have to dig through and see what I can pull for you on that. Okay, let's see. Okay, you all are doing sig fig stuff. Okay, I got you. Okay. Do you have a specific question about molar solubility? And T, if you got questions you want me to answer, let me know that too. And I can just pull some stuff online for you as well. And hello to everybody that's coming in. Hey, Justice, how are you doing? Okay, nomenclature tomorrow. So that's writing chemical formulas. Okay. Okay. All right. So I had to grab. Okay. Let's see what I can do for molar solubility. I do believe we did some questions about this earlier, this past semester. So let me see what I can do for you. So give me 1 second. Okay. Okay. So for instance, I'm just going to type this out. That deals with KSP. Okay. So I'm just going to kind of write the question out so you can see that. Okay. So for that particular question, let me highlight what you just wrote. Okay, so how do we calculate the solution with 2 times 10 to the third molarities of cesium with a +3 charge? And they also gave you the iodate charges of precipitation as well. And will cesium iodate precipitate? Okay. So for a question like that, I might need some more information, but let me see what I can do in terms of this question I'm going to put on the screen. When it comes to solubility, okay, what you have to remember is that you don't include solids in your product. And also, if you're told to write the expression for it, we're going to start with the basics first, okay? So we're going to write the solubility expression for it. Ca subscript 3. So I'm just going to erase this right here so that I can show you all what we're talking about, okay? So when it comes to solubility, there are some ground rules you'll need to know. Okay. So you've got PO4 and then the 2. And what we need to do is write the equilibrium expression. Okay. So I'm just basically writing out part of this question, okay, that's in my book. And I'm going to use my pen to actually describe what you're supposed to do. All right, so this is the problem right here. It says write the expression. Let me take this out. Oops. Okay, write the expression for this constant, for this solubility constant. So let me go ahead and take this out right here. Put that there. Okay, so I'm going to use my marker on the screen so you guys can follow along with me. Okay, and this is what happens whenever we go live. We're having to write out information and take our time. So I appreciate you guys bearing with me for this question right here on the spot. All right, so here's what you've got. Okay, you've got to write the expression for this solubility constant. Now, first thing you need to do is write out the formula that they gave you. So it was Ca3, PO4, 2. Now that is in solid form. And because this is a molar solubility question, the reaction is going to be in equilibrium. Now, what you're going to also do is you're going to put calcium here with the +2 charge, right? And this is aqueous right here. And then you're going to also put PO4. You're splitting them up into their ions, okay? That's what you're doing at the moment. You're splitting them up into their ions. Now, what you also have to realize too is that the ions need to be balanced for what you have on the left-hand side. And since we have 3 calciums on the left, you know what we're going to have to do? We're going to have to put a 3 in front of the calcium ion here. We also have 2 phosphate ions on the left, right over here. So we're going to have to put a 2 right in front of the phosphate ion on the right. Now, in order to do this problem, the rule states that whenever you break them apart, you're going to raise each of those ions to the power of whatever the coefficient is in front. So if you have to write the KSP for this expression, you're going to say KSP equals, and you're going to always put your products over reactants, okay? It's always going to be products over reactants. So in this case, you're going to put the calcium ion with the +2 charge raised to the power of 3. Then you're going to put your phosphate ion raised to the power of, with the -3 charge raised to the power of 2. Okay, now that 3 doesn't look like a 3, so let me go back and redo that. Okay, there we go. Raised to the power of 2. Okay, now here, we're doing English, I think. Is that what you're asking? I don't speak Spanish. Then if you were to look in like at the end of your chapter book, they'll tell you what this expression is equal to. So for this particular format of what we wrote, the KSP for these ions is equal to 2.0 times 10 to the -29th power. Again, that's something that you have to look in your textbook for. Yes, Sophia, yes, this is considered to be the equilibrium expression. Correct. Correct. But you never include solids in your expression. It's always your aqueous solutions. Okay, always your aqueous solutions. So the first thing you would want to do, or want to make sure that you do rather, is write out your compound and then, yes, and then you break them apart into their ionic expressions. So for the ice table, for a problem like this, you can But for a problem like this, where you're just given these two variables, you don't have to do the ICE expression, okay? The ICE expression is not required for this particular part. Now, what I can also do is do a problem similar to this, where you're actually going to plug in the numbers to solve these answers. So it depends, but yeah, in some cases, let me tell you how you know to use the ICE expression. You use the ICE table if you are given the molarity of them. Okay. So if they give you the molarity of each of those individual ions, then yes, you would need to use the ICE table to complete this process. Good question. And thank you guys so much for liking the live. Make sure that you all also share if you have friends that are taking chemistry also. And don't forget to tell a friend that Professor TK the Chemist is live right now doing free tutoring during this month of June. During the month of June. Now, if you are given a problem of this nature, oh, yes, Sophia. Thank you for saying that. Let me tell you, if you're taking AP chemistry, you're talking about when you guys go back to school in August, make sure you start looking over your chemistry notes, okay? Because AP chemistry is very, very detailed, and most chemistry teachers aren't going to take any shortcuts, and they're going to be very firm in what they do. They're going to assume that you remembered all of your notes from your regular chemistry class. And if you took honors chemistry, hopefully you kept your notes. All right. Now, I know that, let me see, let me go back here. T. Scott said that they were doing nomenclature. Do you guys know what nomenclature is? Nomenclature is pretty much when you are writing out chemical formulas and compounds. Okay, so if you're doing nomenclature, you're just pretty much writing out chemical formulas and compounds and learning how to write charges and all of that. Thank you, thank you, thank you. I appreciate you. Thank you so much for your kind words. Okay, thank you, Claude, for the follow. Appreciate you. Okay. Do you guys have any other questions or any other concerns about anything else that you're learning in your class? Because what I was going to do tonight. Hey, Aaron, how are you doing? How's that chemistry class coming so far? You know I gotta ask. What are y'all working on? Okay, what are y'all working on now? Because somebody asked me a general chemistry 2 question a second ago. So what are you guys doing now in general chem 2? Okay, what does that mean by permission number? Okay. Oh, that's right. Oh my gosh. Okay, okay. So, do you have any question? Like, do you remember what you needed to know for general? Like, what did y'all do today? That's what I want to know. What did you guys work on today? Also, let me see. Now, Eunice, and I don't know if I'm mispronouncing your name. What else are you all working on also since you're in summer school as well? To review solubility, okay? And it was just a review of forces and polarity. Okay. Yep, likes is all likes. Yep. Okay. Thank you, Naya. You know what, too, guys, like, okay, KSP and molar solubility. Let me see if I can find those questions for you because I've done several of those problems as well. So I'm gonna have to pull up some stuff. Okay, yes, chemical kinetics. Yes, chemical kinetics. Yes, yes, yes. I am trying to find. Mm, let's see. I'm trying to look up some information for you guys on for the molar solubility. I'm trying to find some stuff for you. Molality and molarity. Yep, yep. I don't know if this. Okay. Yes, and I don't know if this will help. I know again when we do now with molality, yes, molality and molarity are different. So you do know that whenever you all are doing these problems, you got to make sure that you read through each of the examples because there is a difference between molarity versus molality. Okay. So make sure that you guys are able to find and know the difference between them. But yes, I'm still trying to look up chapter 13. Now, what book are you guys in for chapter 13? Because I know for most general chem 2 classes, chapter 13 will be the properties of solution. Boiling point, where you're calculating the KB. Yeah, still dealing with molarity, McGraw-Hill. Okay. 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 Thank you, Emily. Well, you know what? We can also look at that too with molality and molarity. I think I may have had, well, I do. I did have some of those questions too. Like with molality right here, if you guys can see that, let me switch the screen also so that those of you all that are on YouTube can see this too. So with molality, there is a difference between molality versus molarity. And as you guys can see, Kenneth, you never forget what you learned. For some people, it's a nightmare. Yes. But with molality, you've got to remember there are certain key points of what they're going to tell you. For instance, right here, if you look at this formula, delta TF, the freezing point, is equal to KF times M. And TF means a change in the freezing point. KF is the constant given for the solvent. So you have to know the difference between a solute versus a solvent. And if you have a solute that's given in the problem, like this example here, you're going to have to know to convert those grams of solute to a mole. So for instance, they give you what's the freezing point of a solution of 210.0 grams of glycerol. And then they give you the formula for that. And it's dissolved in 350 grams of water, which is a solvent. So you notice that this is the formula here, moles of solute divided by kilograms of solvent. That means your solute that they gave you here has to be converted to moles. So you'd have to know the molar mass of glycerol to then convert that to a mole. And then you have to convert your grams of water, since that's your solvent, convert that to kilograms. Hey, Kim, thank you so much for sharing. And how are you doing today? Yes, so that you guys would know, again, in order to do your conversions, okay? So as you all can see here, okay, fantastic, fantastic. So as you guys can see here, I gave you the information, the numbers of what you have to do, and now all you got to do on the next part is to solve it, okay? Same thing over here. As long as you're given the compound, you find the molar mass for the compound, and convert the grams of the solute to moles, convert the solvent to kilograms, and then just divide those two numbers out. Okay. Any other questions from anybody else? Any other questions? Because yes, I know when for those of you all that have mentioned that you're taking chemistry during the summertime, that's a lot of work. Yes, so Thalia, yes, it has to be in kilograms because that's the formula right here. Let me show you again. Okay. Okay. Okay, you hold tight. Let me pin your question real quick. Let me see. Okay. Let me see. Yes, it does have to be in kilograms because remember, whenever you're looking at the formula right here, okay, the formula is for molality, it's the moles of your solute divided by your kilograms of your solvent. Okay, the moles of your solute divided by the kilograms of your solvent. Okay, and can you go over rates of reaction next? There is a slow one and a fast one for the reaction. Okay, so rates of reaction. Let me go through, let me find this one for you. Okay, Alan wants to know what's the difference between molality versus molarity. Okay, molality, which is what you see here, is moles per kilogram. Moles of the solute divided by the kilograms of the solvent. Molarity is when you're dealing with the moles of a solution divided by the liters, okay, of that solution. So let me go ahead and put the formula so you can see what I'm talking about. Okay, so molality, it's like a funny shaped M. So it's the moles of your solute divided by the kilograms of your solvent. Molarity is the big M. That's the moles divided by your volume. Thank you, IDC Beto. Thank you. Yes, so that's the difference. One deals with a solute and solvent in terms of unit-wise moles and kilograms, whereas molarity is moles per liter. Now, you want to know about rates of reaction. Let's see, rate laws. Thank you here for the giggles. And Sophia want to know about Le Chatelier's principle. Okay, we can talk about that too. So when it comes to your rate laws, one thing you have to know, of course, is how the reaction is given and to know the steps that you are needing to go through in order to solve your problem. Okay, so for those questions, those take a little bit more time to actually go through. But what I'm going to do throughout the summer, I'm going to actually be writing up or doing rather different examples to give you all bite-sized pieces of information. So I'm taking screenshots of your questions so that I can incorporate them into my lives. Okay. So rates of reaction, I will go over that one and give you further detail when it comes to that. But what you have to remember again is that it's the products over your reactant, and you want to make sure that you use the appropriate letters. And if you have numbers, meaning coefficients, you're going to raise them to those powers, okay, in order to do that. So, like, if I give you, for instance, I'm going to just say A and B. That way you guys can get it, okay? So if I say, for instance, A, these are some hypothetical compounds, plus B, that's going to give you your products, okay? Whatever your products are in this particular case. Your rate would be equal to your K constant times A times B, okay? A times B. Now, on the other hand, okay, if I give you, let's say A plus A, again, it's going to give you your products, okay? Then your rate would be written as K times A squared because you have two of those. And again, if I had A, let's say plus B plus C, again, to give you your products, then you're going to say your rate is equal to K times A times B times C. Whoops. So in this case, you would say rate is equal to K times A times B times C. And of course, if they're giving you numbers in your problem, you want to make sure that you're using the proper steps. Okay. So let me give you an example. Okay. I'm going to write one out for you. No, you're right. General chemistry isn't easy, but you can do it. Okay. You can do it. Let me screen share a different one, a different screen, so that way I can have some space. So right here, okay, to give an example of using the rate law, okay? Right here, suppose I had O3 grams, okay? I'm not grams, gas, okay? This is ozone reacting with nitrogen monoxide. That's going to produce nitrogen dioxide plus oxygen gas. Okay, what do you have to do in this particular case? You're going to predict the rate law based on what's given, okay? So the rate is going to be first order, in which you have your reactants and your second order overall, okay? So in this particular case here, we're going to say rate is equal to K times oxygen, the ozone rather, times NO. Okay. This is first order. And how do you know that? Because there are coefficients, imaginary coefficients in front. There's an imaginary one right there and an imaginary one right there as well. So that's why you're going to write this as your overall rate law. Now, someone else asked me a question about Le Chatelier's principle. Sophia, are you still here? I did do some problems earlier also about Chatelier's. Okay, good. About Chatelier's principle. Let me see if I can pull that up, okay, for you as well. Now, are you in summer school as well, Sophia? Let me see here. I have a couple of things I can kind of give you all. Let me screen share. Oh, you got summer work. Got you. Okay. No, you're right about that, K-Doll. You are right. Chemistry is a very challenging topic. How you're welcome. Chemistry is a very challenging topic. It takes a lot of studying, that's for sure, especially when you're doing it during the summertime. That's when it's very hectic. So with Le Chatelier's principle, one thing I recommend that you do is to have charts in your notes so that you'll know some of these rules right here. Okay. So with Le Chatelier's principle, this is when you're having a stress, like a change in conditions, and it's placed on the reaction at equilibrium. So the equilibrium, it will either shift to the left or to the right. And put a screenshot of this on my page so that you can actually go through it right here. And it tells you if you're adding more reactant, when you're putting that stress on it, then the reaction is going to move forward. If you remove your reactant, it's going to reverse. If you add product, it's going to reverse. If you remove or add product, rather, I'm sorry, it's going to reverse. And if you remove product, it's going to go forward. So as you guys can see here, there are different conditions that you can apply to know whether or not your reaction is going to go to the left or to the right or have no effect at all. But you guys can actually go and check this chart out on, it's kind of like organized and itemized on my channel so that you guys can actually find this. This one deals with Le Chatelier's principle. Okay. So for those of you all that are hopping on, we're doing General Chemistry 1 and partially General Chemistry 2. You're welcome, Sophia. You're welcome. And we're just trying to get questions because we oftentimes have different students that hop on needing different goals. And so I'm just trying to figure out what you all may need help with as I'm on my lives each night. I go live Monday through Thursday, 7 p.m. Eastern Standard Time. Thank you, Noah, for sharing the live. Okay, do you guys have any other questions? Okay, so for those of you all, yes, thank you, Noah, I appreciate that. And yes, K-Doll is giving you some good tips. Make sure to take very good notes and listen to your teacher closely. Ask questions. Yes, yes, yes. Thank you, Noah. Appreciate you. Thank you, Mama Cross. Appreciate you. I'm gonna tell y'all another thing too. When you all are taking chemistry for the first time, it can be overwhelming. KSP reactions, yes. Let me see. What do you want to know about KSP reactions? Because we kind of, oh, that's a good thing. Hey, Melton, thank you. Okay, how to solve when there's a precipitate? Okay. Let me see what I can do for you on that one. Let's see here. Okay, okay. Yes, Bone 2, I go live Monday through Thursday, 7 p.m. Eastern Standard Time. Matter of fact, if you guys can tell me in the chat, where are you all from? I used to go live during the daytime at 12:15, Monday through Thursday. During the semester, this past spring semester, I went live daily. But now that summer school is in session, I know a lot of students are able to hop on at night. Okay, New Jersey. Okay, Chicago, Chi-Town, Brooklyn. All right. Okay, Angel, you said you're nervous to take general chemistry since the last time I took it was my sophomore year of high school. Okay, well, listen, you can do it. I would just recommend that you look at my videos or go get your chemistry book from the library and just kind of familiarize yourself with some of the notes and some of the information. I mean, even if you don't understand anything, at least from being familiar with it will help you when you take it during the fall. Louisiana, all right. California, yes. I always get a lot of love from the Cali students. Minnesota, all right. Okay. So we've got students pretty much on all of the coast, the north, the south, the east, and the west. Okay. What I'm going to do, let me see here. I'm taking screenshots of your questions. And also, if I don't address it on the live, I will go back. Matter of fact, I'm glad I said that. What I want y'all to do, when you got questions that I'm not able to answer right away, go to my last video, that the one that says going live at 7 p.m. And what I want you all to do is to write on there what your questions are so that I can do a video response directly to you. Okay. So yeah, do that one, do that favor for me. That way I will remember to go back and answer your questions. Okay, comprehensive video on acids and bases. Okay. What's the pKa value? Okay. Yes. Okay. You guys are asking a lot of great questions. Yes. Now, for those of you all that are asking questions, are you all in summer school right now? And hey, Caitlin, and if you are in summer school, I want you all to write in the chat box. If you're in summer school, write what week it is for you in summer school and what chemistry class are you taking? Keith, you said you failed chemistry last year. Oh no. Hey, Sunny, yes, I do help with AP chemistry. Yes, I sure do. Organic chemistry, let me tell you, pay attention to class. Okay, you're trying to do this for the MCAT. Okay, and then you said you have summer work for AP chemistry. So tell me this, guys. Yes, AP, yes. Oh, now I would be pissed too. Shots. Your professor would not round your 89.48 to an 80. Oh my gosh. Some of these professors be on that petty Annie bull. Okay, Mountain, you need in chemistry for the T's test. Okay. Okay. Yeah, you know what? I'm gonna tell y'all right now. Those of you all that are in, yeah, I would have been pissed too. Oh shoot. Y'all gonna make me start cussing on here. Yeah, so I'm telling you, some of these professors are on a power trip, and some of them feel if you didn't earn that extra little half of a point, you don't get it. And I know that depending on what you were doing during the rest of the semester could determine how that teacher feels. Yeah, yeah, yeah. Yeah, but and if you're not a chemistry major, I mean, my thing is most students, although you want to teach students a lesson, I mean, you were that close. And I know I've talked to some of my colleagues and they tell me the same thing. An 89.48 is not an 89.5. And I'm like, whatever. If you see that a student has been working hard and they oopsie up on one test, that one test should not affect their overall grade, especially when they participated a lot, they did all their labs. They did everything they were supposed to do. That's being petty to the nth degree. Yes, titration labs require patience, especially if you over titrate it when you're dealing with phenolphthalein, because it can go overboard where you have to start all over again. Sophia, you don't have to be scared. Thermochemistry is the bomb. I love thermochemistry. You can easily make mistakes also, though, with thermochemistry. You're taking AP calculus and AP chemistry? Woo-wee. That's beast mode. That is beast mode. You and Gibbs are both homies. Oh, well, you know what, Sonny, you got this. And Sophia, don't be scared. Just continue to do the things that we're doing over the summer. As I go live, you can ask me questions. But can y'all tell me, like, what AP assignments, AP chemistry assignments do you all have to do? It's probably a lot of reviewing for General Chem 1. Mm. Okay, yes. General Chem 2, yes. General Chem 2, make sure that you kept your notes from General Chem 1 because there will be some review there. Hey Jess, JB, how you doing? Yes. A lot of you guys are giving good tips to each other, which is a good thing. Yes, that is true. The acids and bases unit is one of the most challenging. Yes. And I would recommend that you all binge watch videos of people such as myself and others that are good at teaching you all some of the tips and tricks to maneuver around that. Hey, Tequila. Hey, Nadia. No, don't say that. Sugo or Sun GMO, don't say that. I just did a whole series on what to expect for the chemistry regents exam. What do you think you're gonna fail on? Yes. Okay, to all that. Yes, that's true too. There are so many teachers that have different teaching methods. They assume that you know material from the previous section, and they also assume that you remembered it and that you didn't forget. Everything is repetitive, though. I am a college professor. I teach, most of my students are general chemistry 1 students. And I also teach intro to chemistry for students who are going into the nursing program. Yes. Yes. And I go live daily, Monday through Thursday. Monday through Thursday. Yes, that's what I'm telling you, Shaz. I I would, because I know what students are capable of. I know how my students are. I'm not being petty like that. Unless you gave the teacher a hell of a time. Okay. And even still, being petty to not round off, we're talking 2/10 of a point. Yes, it's not that serious to me. I'm like, take the A and leave. You know what I'm saying? Like it's not that serious. And unfortunately, oh my gosh. So you know what? Mm, I would talk to them. I mean, I know, well, and I know you've already done your review, but mm, did you keep all of your papers and all of your notes? Did you look at your final exam to see what you made, like to see if he graded everything? What do you mean? There ended up being too many K's. Oh Lord. Yeah. Ooh. Some of these teachers are just off the freaking chain. Connor, what's your chemistry fine? Are you in is this general chemistry one or is this high school chemistry? What are you taking? Okay, high school honors chemistry. Okay. Do you remember? Oh my gosh. Ice cold tea. Y'all's teachers are something else. Oh, you had the ACS one. Okay. Okay. Oh my gosh. Woo, you could not pay me to be a student in y'all in today's time. It's so much stuff going on. Yes, the ACS test is tricky. Yes. There's so much. Let me tell you, the ACS chemistry test is similar, in my opinion, to like the New York Regents exam. And we're here, I'm in North Carolina. And whenever I would test my students or quiz them, I would give them questions similar to New York Regents exam, because for high school students that are taking chemistry on the level that the Regents exam was given, shoot, they have no problems. If they can pass that test, then they can most definitely pass a general chem 1 or 2 test or class. Connor, I'm just going over different things that students are asking help on. And I go live Monday through Thursday, 7 p.m. Eastern Standard Time. But since your final exam is tomorrow, you should be good to go. Amy wanted to know, does this apply to the MCAT? Because they talk about KA and KB. Yes, it does. Yes. Matter of fact, I'm going to do a whole series on the folks that are taking the MCAT and the students that are taking the TEAS exam for nursing. Some of you all have different requirements and different help. Yes, I can, Shaz. Yes, I can do that. Charles, yes. You're welcome, Amy. Yes, make sure that you guys come back through if you need further help. But I know a lot of times you have a good day as well. And thank you so much for sharing your story. I'm sorry to hear that though. Hey, Taylor. Thank you, Cat in the Wall. How you doing today? But yes, guys, when we come on live, I try to make sure it's a structured live. Matter of fact, I'm gonna get off of my YouTube channel because I know I did go live over there on YouTube, and I want to make sure that whatever you all needed help on, that you could get the help that you needed. Because thank you, Britt Chick. How you doing? Am I a fan of the ice tables? I'll say this: it's you can do the ice table, but you can sometimes make a lot of mistakes with it. Kind of like thermochemistry. There are so many different ways in which you could approach those problems. And I do have some of those on my channel, on my YouTube channel, as well as on my TikTok page. Yes, men, that's why I actually, it's funny you say that. That's why I actually majored in chemistry, because I did not like to memorize anything. And that's what chemistry was all about. It was a bunch of memorization.